prove what can happen when three observers are going to try to see the various activities that magnetars can display or put out, starting from our galaxy. So from our galaxy, we have the first observer, observer A. Observer A is counting how many sources that are magnetar-like, and also defining what is a magnetar event. And he is going to be interested in the events of value and of interest to other two extragalactic observers, observer B and C. So he is going to relate and register the events that would be detectable from outside the Milky Way. So he has, the top of his list are three giant flares and one FRB. These are the ones are going to be visible to the two other observers, observer B and C. Observer B is just outside our Milky Way in the local group. He or she can see everything that is happening here. But he or she can see also farther out. And interestingly, he is going to say he can also see 7 GRBs out to 10 megaparsec that are magnetar giant flare light. Plus 1 FRB from the M81 galaxy that is similar to our FRB from 1935. He is a magnetar hopeful, trying to see if those galaxies, if those events which are candidates are confirmed. Our observer A is magnetar rich. We have, so these indeed what observer B is going to have on his playbook. So he's going to say these are the 7, the furthest one out to 4.5 megaparsec, and we have the M81 FRB, and the M81 also is the host galaxy of a GRB that is also an extragalactic magnetar giant flare. And then we go to the third observer, observer C. He is the magnetar lonely guy. He is farther out. He can see out of 10 to the 5 megaparsec. He can see all the population of localized GRBs and localized FRBs. He is lonely because he cannot say anything about the magnetar likelihood of those sources other than the merger, the clear merger, the clear collapsers, and again he is part of the team trying to understand what are the sources of the FRB events. Working together, the three observers are trying to find a way to merge their observations, and the starting point is observer A is going to look at the most interesting source within the Milky Way, 1935, and then he is going to see, look at the X-ray and the radio events. This is the entire history of 1935 from discovery to present, discovered in 2014. 2020 is the remarkable year. 1 FRB and 11 FRB like that, much fainter radio burst. So that first step he can do, look at the X-ray events and look at the radio events and study them together. By doing so, we have four activities. The first one, the April 2024, is the one that gives us the truly FRB class event, and then 2022 October, there are also 3 FRB like or weaker radio bursts. So looking at these together, and we have published the part of this work in 3 ABJ and ABJS paper with 1/4 under review, covering these 4 activities and looking at the radio and X-ray together. So first thing, April 2020 is a truly unique event or episode, judging by the X-ray data alone. So the X-ray data, you can see the slopes, the 2 distinct, non-overlapping black body soft and and hard. So it actually stood out in many different ways. I have to go fast here. I already ran out of 5 minutes. So and we tried to look at it through different lenses, and we can see that the 2020 event or episode is very different and more likely to have been taking place in the polar cap with fireball interaction leading to the FRB1, very different to the other three activities. We compiled all radiobursts, as I said, from 2020 and 2022, studied them with the X-ray bursts of April 2020, and we can see here, this is our 11 F radio bursts, and these are the X-ray bursts. And we can see the counterparts. 3 of the radio bursts have actually X-ray counterparts. They are on the long side. They are longer than the mean of the duration here. And then, so if we are looking at how do the X-ray and radio bursts compare together, duration-wise, the X-ray are 2 orders of magnitude larger, but the radio actually have a larger range. They have a much wider range compared to the radio bursts. If we look at the different X-ray missions, we can see also how the radio range compared to the X-ray range from different observatories, and this is the luminosity and flux and also the fluence. But if we switch, if we factor out the wavelength or the energy, because the radio bursts here are at a disadvantage because they have lower energy. If we factor this out, we can see that the radio bursts actually outshine the X-ray burst in terms of the number of photons per unit, or the photon flux and photon luminosity. And they show comparable distribution when it comes to the flux power law, and also when it comes to the fluence. Also, they show power law, and here you can see that again the X-ray are based on the average. They are brighter by 1,000. But again, when we factor out the wavelength, the radio bursts outshine the X-ray. They also have a much broader ranges, although they are shorter sampling. The same thing happens when we see the fluence as well. The X-ray is much brighter, but in terms of number of photons, the radio actually have a higher ratio, and also the if we also look at the temporal energetics properties, this is how the duration and flux they relate together. And just looking at the timer to stay on time. And if we use the density per unit wavelength, the position of the clusters here switch. So from these observations together, they support the close-in model more than the far-away model. The pulsar-like emission is favored by these observations. And if we take this out now, and again the interaction between the fireballs by Yang and Zhang have been proposed as a mechanism to produce counterpart X-ray and radio bursts. If we share these observations by observer A to observers B and C, they will be able to put together the local with the extragalactic together to paint this phase space, and again group the localized GRBs with the localized FRBs, and we draw here the predictive ranges for the 95% contours for the confirmed magnetar events, and we can see an overlap. We can see some members of the localized GRBs and FRBs, they share the same phase space. If we also look at the fluence distance relation, we can see also a pattern where some localized GRBs and FRBs, they can behave similar to our confirmed events. Looking at the duration with luminosity, we can also see at the interface here, there are common regions for the extragalactic and the confirmed, and the same thing is also seen here with the localized GRBs with the extragalactic magnetar flare candidates out to 4.5 megaparsec and the confirmed ones. So we are able actually to pinpoint some of the GRBs and some of the FRBs that can be from the same galaxy. So looking at the special coincidence and also the Z coincidence, and looking at the possible galaxies in the FOV, we identified a number of pairs, GRB and FRB pairs, that actually appear almost in every correlation, in every possible way that you put together. They appear to be from the same galaxy. We put together also this type of diagnostic where we have the galactic events and candidate events and the new pairs. We can see a trend, a power law trend for magnetar confirmed, magnetar candidates, and new potential ones. And this is the earthquake data obeying the same power law trend. If this is a truly magnetar processes, the X-ray and radio luminosity, it should stand out if we compare to other extragalactic events, lasers, quasars, AGNs. So if we plot the gamma ray versus X-ray, gamma ray versus radio luminosity, we can see there is a region here for the, again, the magnetar confirmed candidates and new potential candidates, very different from everything else that is known to be magnetar events. We can put them together in such type of 3D events. Now, the end outcome is observer C, who was magnetar lonely. He now has some candidates thanks to observers A and B sharing these info together. So the three have read part of the Magnetar Playbook, trying to understand how these sources can exist here and there, appear in different ways. And now they are hopeful or trying to find deep radio and deep optical observation to confirm the new candidates far out. So this is everything we have been doing for the past year or two. So where we come from, I'm originally from Egypt, worked at the American University in Cairo for a very long time. Now I'm in Oman, and this is our small team. And thank you very much. I already exceeded by 2 minutes. Thank you.
Okay, we have time for one question. Everyone's spellbound. They haven't thought any questions yet.
Did you have it? There were so many slides going past us. Did you say that you found coincidences between which galaxies with FRBs and GRBs?
Confirmed host galaxies, there are 3. Out of the published data as of 2024, we have one GRB localized to a host galaxy in a special coincidence with an FRB that doesn't have yet a host galaxy, but the redshift from the DM matches with the redshift of, and then we have one FRB with localized host galaxy that matches with another GRB with not yet localized host galaxies. And the third piece is we have matching Z for FRBs and GRBs with a lot of galaxies in the FRB. Some of them have Z and some don't. So indeed, follow-up observation from these potential sources will be quite enriching.